Alright guys, I'm going to try to film this down here. Hopefully I'm connected to a better Wi-Fi, to a 5G Wi-Fi here, and hopefully the video doesn't pause as much. We'll give this a minute for a couple people to join. We'll get this started. Alright, we'll get this started. Today might be a little bit longer of a session. Hopefully it records the whole thing since we're on a new Wi-Fi here. And we're going to go through a bunch of notes today that we're going to use a lot for the next couple days. So if you got the hang of today, you want to feel free to work on ahead. I would recommend that. It'd be kind of good. So today I'm going to go through some of the notes, make sure you guys understand the rules, and I'll put some examples down too. So when it comes to definite integrals, there's some properties that we can use to help us solve the equation a little bit faster. So first property we're going to start out is like if I take the integral from a to a of f of x dx, what that will always be, if these two numbers are the same thing, no matter what the equation is, if those two numbers are the same thing, it's equal to 0. So an example we have in our notes, if you downloaded the packet, was, okay, if I was going to take the integral from pi to pi of sine of x, there's no point of, taking the integral of that and figure out that's negative cosine and plugging in this one and plugging in that one and subtracting your answers. No matter what these are, because that's the same thing, would be 0. Same thing, if I had the integral from 9 to 9 of x cubed minus radical x plus x to the 3/7 power dx, no matter what crazy equation that is, that would equal 0, since those two numbers are the same. So anytime we have the same numbers in the integral, it equals the same thing. All right, next property that we're going to learn, and we'll have to use, maybe we do have to use this today. I'm not sure if we do or do not. All right, is the integral from a to b of f of x dx is the same thing as the negative integral from b to a of f of x dx. All right, so this one I think the rule's a little bit more complicated than writing down an example. So I'm going to just make up an example. And here we go. So if I had like the integral from like 3 to 10 of, I'm just going to make up a problem like x cubed plus 4 dx. And I knew that was equal to, let's say, 36. All right, I know it doesn't equal 36, but let's say it does equal 36. If I gave you a problem that said, okay, find the integral from 10 to 3 of x cubed plus 4 dx, if this is the exact same problem except for the numbers are switched around, it's going to equal the negative answer of that one. So since this answer was 36 and this is the same problem except for the numbers are switched around, this one would be a negative 36. So if we ever have the same integral but the numbers are flipped around, it's going to be a negative answer. Okay. We got another property that we'll go over tomorrow. A little bit more detail, but it's good. We'll just talk about it today in this notes. It is the integral from a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. So what this means is, like, say I have a function and I'm trying to find the area underneath the curve from point A to point B. So I'm trying to find this region here. all this is saying is that you could pick a point in between A and B, name it C. It doesn't have to be in the middle or anything like that. So C, if I take the area from A to C and add on the area from A to B, it'd be the same as just taking the whole integral from A to B. This is nice to use when we have a more complicated function, something like an absolute value, that we could break it up. And tomorrow we'll look at some more examples of how that can be used. Okay, the last two problems are ones that we'll kind of focus on today. Let's see. The integral, oh, I lost focus, there we go. The integral from A to B of k times f of x dx is equal to k times the integral from A to B of f of x dx. All right, so this one's, once again, a little confusing the way it's written. I think it's easier to understand with an example. So let's just say, like, I took the integral from 7 to 10 of, let's just say, x dx, and I got that equal to, let's say 12. Okay. So what we can do is use that to help us find another answer. So say if I had the integral from 7 to 10 of 4x dx, well, if I know that a regular x from 7 to 10 is 12, if I have 4x from 7 to 10, all I need to do is take 4 times 12, and that would be 48. So that's a property we can use. If we ever have a multiplication here, if we knew the answer without the multiplication, all we could do is multiply. Same thing actually works with division too. And then the last one, pretty self-explanatory in my opinion. I don't get why they put this one last. I think it's the easiest one to understand. But the integral from A to B of f of x plus or minus g of x dx would equal, I'm going to have to write this over here, the integral from A to B of f of x dx plus or minus the integral from A to B of g of x dx. So what this means is if we have an integral from A to B of like x squared plus 4 dx, we could break this up into the one integral here and then add the other integral there. We'll do that in today's quiz. All right, so there's the notes. We're going to use those notes for some time now. What I'm going to do is kind of help you out with the homework problems. And I'm going to get that loaded up here in just a second. Had a couple people take this already. They must have taken it yesterday and they got a 4 on 4 on it. Okay, so there are a couple properties, or the couple examples they give us that we're going to use the whole time. So they say the integral from 2 to 4 of x cubed dx is equal to 60. They also say that the integral from 2 to 4 of x is 6. And then they say the integral from 2 to 4 of just dx equals 2. I'm going to tell you a hint here. What that technically is a 1 dx. We'll have to use that later on. So what we need to do here now is to answer these questions. So if we know that, first problem is asking us, okay, what is the integral from 2 to 2 of x cubed dx? Well, using the properties that we know, since these two numbers are the same, it doesn't matter. That's going to be 0. So anytime the numbers are the same, your answer is going to be 0. Okay. Next problem. All right, the integral from 2 to 4 of 25 dx. Okay, so we're going to use these answers up here to help us out. Notice the 25 doesn't have any x's, so we're not going to use the x cubed, we're not going to use the x. We're actually going to use the 1. What we have to remember, though, that we can multiply the answer by any constant. So instead of setting this equal to 2, which that's what 1 dx would be, we're going to take 25, our constant, and multiply it by the answer. So 25 times 1 is 25. So to get the answer, we're going to multiply the answer of 2 times 25. That'd be 50. That one I think is kind of tricky to understand. It's hard that they do that right at the beginning. Okay. Maybe the next couple examples will help you out understand these properties. All right, if we got the integral from 2 to 4, so all these numbers are staying the same, of x cubed plus 4 dx. Well, what we can do is to break this up into just a couple parts. First off, the x cubed is the exact same thing as the x cubed up here. So this part is going to be 60. All right, then we got a plus sign. The next part we have 4, which remember 4 is like a constant, like how 1 is a constant. But since it's 4, not 1, we're going to have to take our answer of 2 and times it by 4. So we get 60 from the x cubed, and we get 4 times 2 from the 4. And so we're going to get those two answers together. So the answer there would be 68. Alrighty, one more problem. Alright, so if we got the integral from 2 to 4 of 10 plus 4x minus 3x cubed dx. Alright, so let's break down where everything comes from. First off, we have 10. 10 is a constant, so we'll use our constant answer there to help us figure that out. But it's not just 1, it's a constant of 10, so we're going to have to take our 2 and times it by 10. And then we move on to the next part. The next part is 4x. Well, x we'll use up here. If it was just a plain old x, a 1x, it would be 6, but it's a 4x. So we have to do 4 times 6. And then lastly, we have a minus here. We have 3x cubed. The x cubed would be 60, but it's not just a 1x cubed, it's a 3x cubed, so we'll do 3 times 60. So we're going to take those numbers, figure out what they are. All right, so this would be what, 20 plus 24 minus 180. All right, so what's that? 180 minus 144, is that negative 136? I think so. Double check the answer real quick. Yeah, negative 136. Okay, so hopefully that helps you with the homework quiz. I'm going to just go take a look at tomorrow's quiz too. So tomorrow's quiz is very similar, except for it uses the breaking up properties. So I'll be on again to help you guys out with that. But there we go. Okay. Be good? Did the video record the whole time? Hope it did. Okay. I'll post this video on YouTube again, and I'll post it on my story, but hopefully we got a better connection. All right. We'll see you guys tomorrow. Have a good day. Awesome. Stay safe. And the video